Hello and welcome everyone. My name is Pranav Chasra and I'm a Senior Product Manager for AWS Local Zones. Thank you for joining me to learn about local zones and how they enable developers to run applications that need single-digit millisecond latencies to the end users across the US. In today's session, I'll describe what AWS Local Zones are, why we build them, and which locations can developers use them. And next, we'll discuss how developers are already using these local zones. And finally, we'll dive into the developer experience. So first, let's discuss the key components of AWS infrastructure and where do local zones fit in. If you look at our infrastructure, it spans across 77 AZs within 24 geographical regions around the world today. And we have announced plans for 15 more AZs and 5 more regions in countries like India, Indonesia, Japan, Spain, and Switzerland. And at AWS, every region consists of multiple availability zones, typically 3 or more, each of which is a fully isolated partition of infrastructure that consists of discrete data centers. And all these regions provide full redundancy and connectivity back to the network. If you look at last 14 years so far, Amazon Web Services has been the world's most comprehensive and broadly adopted cloud platform. So why did we launch local zones despite having 24 regions across the world? And the answer is driven by developers' expectations. Developers have told us that they have a significant number of applications that they want to run in the AWS cloud across the world, and the vast majority of developers get the necessary performance for their applications in public regions. However, for some of the more latency-sensitive and throughput-sensitive workloads like real-time gaming, machine learning, inference, and live video streaming, developers want AWS closer to their end users. And these latency-sensitive workloads have traditionally required customers to procure, operate, and maintain IT infrastructure in their own data center or co-location facility, which typically adds to the cost and operational complexity. And developers also told us that they had to build and run these low latency application components with a different set of APIs and tools than the other parts of the applications running in AWS. And that's why, based on your feedback, we launched different AWS Edge offerings, including AWS Outpost, AWS Local Zones, and AWS Wavelength. Let's discuss them briefly. So AWS Outpost is a fully managed service that extends AWS infrastructure to virtually any data center or on-premise facility for a truly consistent hybrid experience. It is designed for workloads that need to remain on-premises due to latency requirements. However, not every customer wants to operate their own on-premise data center. In fact, there are customers who are interested in getting rid of their data centers entirely. And that's where AWS Local Zones come into picture. Local Zones allow such customers to gain all the benefits of having compute and storage resources closer to the end users without the need to operate their own data centers. Now, on the other hand, Wavelength is designed to deliver ultra-low latency applications to 5G devices by extending AWS to the 5G networks. And specifically, Wavelength embeds storage and compute inside the telco providers, which is basically the 5G network, which help developers build new applications for the 5G end users. And all of these three edge offerings bring AWS services to more places with the same experience and benefits that developers are used to today. So how does local zones work? Let's take an example of US West Oregon region. We know that the latency of the application deployed to the region depends on where the end user is, where the region is, and the specific path that traverses from the region to the end users. And typically the latency in the region is in the order of tens of milliseconds if you look across the broad population of end users. What AWS Local Zone does is that it brings the AWS services to the edge in the metropolitan cities, which basically minimizes the latency required to connect to the end user. And logically, you can think of AWS Local Zones as very similar to AZs in the region, is that local zones are not physically co-located in the region, they instead lie in a different physical geography. For example, in the case of LA Local Zone, what we have done here is that we have extended the US West Oregon region into the LA metro area by building 2 local zones in LA. And since the latency which is required from the end user to the local zone in Southern California is lower, this can be essentially used for applications like gaming and hybrid migration where low latency is important for all these workloads. So now that you have understood the edge offerings and local zones briefly, let's discuss more details about local zones and their benefits. First of all, AWS Local Zones are managed and supported by AWS, meaning customers longer need to incur the expense or the effort of procuring, operating, and maintaining their data centers in various cities to support the single-digit millisecond latency experience. Secondly, applications in the local zone use the core services available today, such as Amazon EC2, Amazon EBS, Amazon ECS, and Amazon EKS. And local zones also provide developers a high bandwidth, secure connection between their local workloads and those running in the parent region. What it does is basically it provides developers the ability to use the same APIs and tools to run latency-sensitive workloads locally while they seamlessly connect to the full range of services back in the parent region. And finally, local zones deliver a consistent developer experience across the US, allowing developers to build applications using the same familiar AWS services, APIs, tools, and functionality that they use today in the region today. The next question that we get from customers is, where can they use local zones? And until last month, developers could only use LA local zone for the end users located in the Southern California region. However, developers outside the Southern California also wanted this capability for the end users across the US. And that's why, based on your feedback, we launched 3 new local zones in Houston, Boston, and Miami in Andy's keynote last week. These zones are available in preview and you can start using them right away. We also announced plans to launch 12 more local zones throughout 2021, covering cities like Atlanta, Chicago, Dallas, Denver, Kansas City, Las Vegas, Minneapolis, New York, Philadelphia, Phoenix, Portland, and Seattle. With these local zones, developers will be able to deliver single-digit millisecond latency experience to end users across the US. Now that we have discussed why we build local zones and their presence in the US, let's discuss how developers are using these local zones today. As I discussed earlier, local zones can be used for highly demanding use cases that require single-digit millisecond latencies to the end users. These use cases include media and entertainment content creation that require latency-sensitive workloads for live production, video editing, and graphic-intensive artist workstations. Next, we have real-time multiplayer gaming use cases where developers deploy latency-sensitive game servers in local zones to run real-time multiplayer gaming sessions so as to maintain a reliable gameplay experience across different locations. And then there is an enterprise migration use case where customers use the local zone to migrate complex legacy on-premises applications incrementally to AWS while they maintain a hybrid architecture. And finally, we have machine learning where developers are able to easily host and train models for high-performance, low-latency inferencing in local zones. And there are other latency-sensitive use cases like live video streaming, AR, VR, and others where customers can use local zones in similar fashion. Now that you've understood the use cases broadly, let's discuss some of these top use cases in detail. So first, we have M&E customers like Netflix and Meta Studios who are either migrating on-premises workstations, which are very expensive, or doing video editing in local zones. And they do this to accelerate content creation by getting rid of the on-premises capacity constraints altogether, while they improve the security and operational efficiency. And for artist workstations, latency is a key to having a jitter-free experience on a remote instance. And these customers typically require less than 5 millisecond latency from their offices or the animation hubs to the virtual instances in the local zone. And with Direct Connect, most of our customers are able to achieve as low as 1 to 2 millisecond latency from the animation hubs to the local zone, and they're able to run latency-sensitive workloads like live production, video editing in the local zone closer to the artists. The next top use case we see is a real-time multiplayer gaming, where gaming companies deploy game servers for multiplayer sessions worldwide to be closer to gamers. And when it comes to gaming, a latency of 30 milliseconds or less is considered ideal for the good gameplay experience. And until now, these customers were using on-premises installations in various metropolitan cities to supplement AWS presence. However, now, customers can deploy latency-sensitive game servers in local zones to run real-time and interactive multiplayer gaming sessions, which basically enables them to provide end users across the continental US with a great and consistent experience. The third important use case that we see is the enterprise hybrid migration, where various enterprises have workloads running in their existing on-premise data centers in various metropolitan cities. And these customers are using AWS Local Zones to migrate complex legacy on-premises work applications to AWS without any expensive revamp of their architecture. Customers like Mindbody have told us that it can be daunting to migrate a portfolio of interdependent applications to the cloud. And now with Direct Connect to the local zone, these customers can establish a hybrid environment that provides ultra-low latency communication between applications running in the local zone and the on-premises installations. In turn, this enables customers to migrate applications incrementally, which basically simplifies the migrations drastically and enable ongoing hybrid deployments across the US. And finally, there are use cases like machine learning inference, where customers have to gather, process, and analyze data from millions of smart devices. And for such use cases, network latency impacts the ability to provide customers with real-time insights and recommendations. An ever-increasing complexity of customer inference queries needs more time for the computational response, keeping less time for the packets to travel to the compute. With local zones, these customers are able to deploy inference and search servers in local zones in cities across the US and achieve a single-digit millisecond latency experience, which basically results in much faster insights and recommendations for these developers. Now that we have reviewed some common use cases of local zones, we want you to get started with these zones. So let's dive into the developer experience. From the perspective of services, we support select services locally in local zones. For example, we launched our first local zone with support for Nitro-based EC2 instances, EBS Volume, Amazon VPC, Amazon Application Load Balancer, Amazon FSx for Windows Server, Amazon FSx for Lustre, and Amazon Direct Connect. And since then, we've added support for Amazon RDS, Amazon EMR, AWS Shield, Amazon Elastic Cache, Amazon ECS, and Amazon EKS. And we're further adding more services based on developers' feedback. To get the complete list of services supported in local zones location that you're considering, please visit our features page on the local zone webpage. Apart from local services that I discussed just now, various AWS tools work in local zones as well. For example, API calls are automatically logged via CloudTrail, and developers can continue to use familiar and powerful AWS services like CloudFormation, identity and access management, and auto-scaling to basically manage, secure, and scale the applications in these local zones. And you can access AWS services such as Amazon DynamoDB, Amazon S3, and others in the parent region in the same way you do in the cloud today. So the next question is how to get started with these local zones. The local zones are accessible from API endpoint and the console of the parent region. To get started, you first need to enable the local zone for your account before you can start deploying resources to them. You can do that from the new zone settings section of the EC2 console, as shown here. A key caveat here is that while you can self-enable the LA local zones, which are generally available, you'll have to request access to the preview local zones, including Boston, Houston, and Miami, which you can do from the same settings page. Once enabled, the local zone look and behave similarly to the AZs. You can access local zones through the parent region's console and API endpoints. The example here shows the LA local zone, which is visible as US West 2 LX1A, along with other AZs in the EC2 console. The US West 2 in the name tells you that the parent region is US West Oregon, and the LAX tells you that the local zone is an extension of US West 2, and basically it physically lies in the LA metro area. Now let's look at some of the concepts of local zones that we can see from the Describe Availability Zones API. The zone name US West 2 LX1A can be passed into APIs like create subnet or create volume, just like any other AZ. And the group name here is used to refer to the group of local zones in a particular metro area. This group, for example, US West 2 LX1, includes two local zones in the LA metro area, both of which are extensions of US West Oregon region. You can also see the network border group as US West 2 LX1 here, which is used to allocate IP addresses that can be used with the EC2 instance in local zones for local connectivity. Now, the applications built on local zones start with the VPC, just like you start applications with the VPC on AWS regions today. So once the local zone is enabled, you can extend your existing VPC from the parent region to a local zone by creating a new VPC subnet and assigning it to the local zone. For example, you can assign the subnet to US West 2 LX1A, which is the LA local zone, and extend the parent region VPC to the local zone using the same subnet. Now let's look at an example architecture here. In this example, you can see the VPC and the subnets linked to the two AZs in the US West Oregon region. And you can extend the same VPC from the parent region US West Oregon into the LA local zone by creating a new subnet and assigning it to the local zone. When you create a subnet in the local zone, your VPC is extended to the local zone, and your VPC treats the subnet just like any other subnet in the AZs. And all the other things like relevant gateways and route tables are automatically adjusted as well. As I mentioned earlier, local zones have their own connection to the internet, and some also support AWS direct connectivity. So resources created in the local zone can serve local end users or on-premises installations with a very low latency communications. Once a VPC subnet is established for a local zone, you can simply select the subnet while creating local resources. For example, you can launch an EC2 instance in the LA local zone by selecting the local subnet as shown here. Similarly, you can launch EBS volumes by selecting the LA local zone in the current APIs and console used for deploying the EBS volumes in other AZs. Once you launch any local resource in local zones, they're ready within seconds, and you can manage these resources in local zones just like any other resource in AZs. For example, here you can see the instance that I launched in US West 2 LX1A, which is the LA local zone, and I can use the same EC2 console to manage the instance that I just launched here. Local zone can also be used to further improve high availability for applications while you maintain ultra-low latency. One scenario for high availability requirement is for enterprise migrations that I discussed earlier. These enterprises have workloads that currently run in existing on-premise data centers in metro area, and it can be daunting to migrate these application portfolios, many of which are interdependent. And by utilizing AWS Direct Connect in conjunction with the local zone, these customers are able to establish a hybrid environment that basically provides ultra-low latency communications between the applications running in the local zone and on the on-premise installations. And as time progresses, the on-premise applications can be migrated to the cloud in an incremental fashion. And the architecture diagram that you see here basically illustrates this kind of enterprise hybrid migration use case. A key point here is that developers can partition their workloads between the two local zones in a metro area, similar to how they partition their workloads between AZs in the region today. And that's how they can achieve the higher availability. Another scenario for higher availability is a local zone is basically virtual desktops for animation workloads. For these workloads, latency is critical, and the addition of second local zone in the same metro area provide developers additional failover capabilities without sacrificing the latency. And finally, from the pricing perspective, instances and other local AWS resources in local zones have their own specific prices, which may differ from the parent region. We include a billing prefix and location name and billing reports, which are specific to the group of local zones in a metro area. All EC2 instances in local zones are available in either on-demand or spot form, and you can also purchase savings plans as well. For exact pricing information, you can visit the pricing section of the respective pages and filter the pricing information by choosing the local zone location in the drop-down. When it comes to data transfer charges, local zones are priced same as any other AZs in the parent region. For example, data transfer between the Amazon EC2 in the local zone and the Amazon S3 in the parent region is basically free. Similarly, data transfer in and out from Amazon EC2 in the local zone to the EC2 in the parent region is charged at 1 cent per GB in each direction. Now that I've explained how to enable local zones and provision applications in local zones, please go ahead and try these. As always, we're listening to your feedback and are working on adding local zones in other locations. If you are an AWS customer with a requirement for a very low latency for your workloads anywhere in the US, then we invite you to check out these new local zones. Thank you for coming to the session today. Again, I'm Pranav Chachra, Senior Product Manager for AWS Local Zones. Thank you for joining.